This is section 10.1 on plane figures or two-dimensional geometry. There are lots of vocabulary words. Make sure you are taking notes. I gave you a note sheet that you could fill in to make sure that you got all the information. To begin with, a mathematical system, the geometry system in particular, is made up of undefined terms. The undefined terms for geometry are line, point, and plane. Definitions are the next part of the system. Axioms, which we assume are true but have not been proven. And theorems, which have been proven. If you had high school geometry, you remember doing proofs. That's what we're talking about when we say theorems need to be proved. Okay, our first word is line. You need to know to please draw a picture of what a line looks like, the blue here, and also please note the symbol to name the line. Okay, next we have collinear. The prefix co means with, so collinear means with or on the same line. Then we have a plane, which is flat like a piece of paper or a tabletop, and it goes on in two directions, where a line, I know it goes in two directions, but it's really one-dimensional. It goes left to right, where a plane will go left to right and up and down, or around in more than those directions. So let's think about a model for a line and a point and a plane. If I had a piece of paper, then a model for a line, well, our paper has lines. So you could say the blue line on the paper, or you could say the edge of the paper. A point might be a corner or a dot. How can models of lines and points be obtained? By folding a sheet of paper. So if I took a piece of paper and folded it, it would make a cross of creases, and those folds, the actual creases, would be lines, and where they intersected would be a point. Okay, the next word is line segment. Notice on a line segment, it's part of a line, so it has two endpoints, no arrows. Also notice that the symbol changes. So the symbol is a straight line over AB. Then we have the word bisect. So we have line segment. You need to know the symbol. You need to know that these are called endpoints. Bisect, bi means two, so bisect is two parts. They need to be of equal length. So basically, if you bisect something, you're cutting it in half, which makes the midpoint the point in the middle. Okay, rays have one endpoint and one arrow, and their symbol is a ray. So rays go on in one direction. Next we have angles. The vertex is, an angle is actually the union of two rays. The vertex is where they share the common endpoint. The rays are called the sides of the angle. I mean, maybe a lot of this you might remember, and you don't have to write everything. If you remember something, don't write it down. But these are the sides. This is the vertex. The symbol for angle, okay, and when something has the same measure, we use M for measure, and then we use an equal sign. So you could say that these two angles drawn have the same measure. Okay, angle measurement was devised by the Babylonians. If you've had 1315, we talked about the Babylonians just briefly, that their number system was based on 60, which then makes more sense because 6 times 6 is 36. So this was 6 60s makes 360 degrees in a circle. There are 360 degrees in a circle. So a degree is made by dividing a circle into 360 equal parts. Now it talks about that you can further divide those into minutes and seconds. You don't have to know that. I'm not going to highlight it here. It might be helpful to know that the Babylonian system was based on 60. That's why it's 360 and not, say, 1,000 degrees or something. But again, I'm not highlighting it. You don't have to know that part. Okay, a protractor is this device. Hopefully you've used one of those. And at the very least, I want you to be able to use a paper version. So on the notes that I gave you to fill in, there's a problem that asks you to write down the measure. Okay, so when we do that, we line up the angle to where the vertex is in the center, and then we're going to read that off. So on this one, I'm going to go from 0 up to where this other side is, so 0 to 60 degrees. And that tells me that my angle is 60 degrees. Types of angles. You need to know that a right angle is 90 degrees. Let's see, we better highlight not in red. Right angle is 90 degrees. Less than 90 is acute. Greater than 90 but less than 180 is obtuse. And 180 degrees, which we often call a line, is also called a straight angle. Okay, reflex angle I think is on the next slide. If not, it's on the notes. Also draw a picture of those. Notice on their angles, you should have arrows at the ends of your angles because angles are intersections of rays, and rays have arrows at the ends. It is customary to draw an L at the vertex of a right angle that's square. If we have an angle that is greater than 180 degrees, it's often called a reflex angle. And we would mark the angle to clarify which one we're talking about with that arc. Okay, in grades 3 through 5, we're going to establish some benchmarks to estimate size. So we want students to be able to maybe show their hands in the form of a 90-degree angle or a 45 or a 120, or to make a 360 or 180 turn, to be able to actually physically estimate some types of angles. Okay, 2 more words. Complementary is when we have 2 angles whose sum is 90. Supplementary, that's these here. These are complementary. 1 and 2 are complementary. 3 and 4 are supplementary because their sum is 180. Next, we have adjacent angles. Adjacent angles share a common side. If 2 buildings are adjacent, that means they're sitting next to each other. So 2 adjacent angles, they sit next to each other, okay? Next, we have vertical angles. So first we need a picture. These that make an X, they're vertical angles. So let's get the definition. Now, I think the definition is harder to understand than the picture, so be sure you put both, or at least the picture is probably more important. They do need to be straight lines, so let me give you a non-example. If I drew here in purple this line, and I know my lines are not quite straight, but just imagine, and then I drew this. Okay, this second line is not a line. These are 2 rays because it turned. So that is not, these are not vertical lines, vertical angles, because it's not two intersecting lines. So they have to be lines, not line segments or rays. Then what happens is, if you'll see here, these two angles are the same, and these two angles are congruent or have the same measure. Okay, on your paper, there's a section on the notes to draw two parallel lines cut by a transversal. So the one labeled T is the transversal. You don't have to necessarily know that, but it's cut by a third line. Next, we have curves. In math, normally when we say the word curve, you're thinking a curved line, but a curve at its basic definition is just a mark. Like this could be a curve even though it's straight. Okay, now let's talk about curves. So remember, curves can also include straight lines. So a simple curve would be like letter A, does not intersect itself. A simple closed curve starts and stops at the same point, like letter B, but notice it still doesn't cross itself. A closed curve, but notice it's no longer simple because it intersects itself. That would be letter C. So even though B and C have straight lines, they're still referred to as curves. Okay, so notice that here we're going to classify these. So notice that number 1 crosses itself, so it is not simple, but it is closed. Number 2 does not cross itself, but it is also not closed, so it is just simple. I'll just put an S for simple. Number 3 is simple because it doesn't cross itself, and it is closed. Number 4 is simple, and it is closed. Now, if it's not concave, then it's called convex. And most of the time when you think of a polygon or our shapes that we've learned, they're convex, meaning it doesn't have any caved in parts. So let's classify these as concave or convex. So I think what I will do is just highlight concave, and we'll say that number 2 is concave, but 1 and 3 are convex. Now your circle definitions. There's a circle on the notes that I gave you. You need to know all of these, that the center, the definition of a circle is actually each point on a circle is the same distance from a fixed point called the center. Okay, so a lot of times I'll ask students, what is a circle? Well, it's the round thing, the round shape. But a circle is actually a simple closed curve whose interior is a convex set. That sounds crazy, but that's what it is. Then we have the radius, which is halfway across the circle. A chord, which goes anywhere from side to side on the circle. Okay, then we have a diameter, which goes from side to side, so it is a chord, but it also goes through the center, so it's a special chord. A tangent intersects the circle in exactly one point, so it just barely touches the circle. And then you have circumference, which is the distance around the circle. Now I know I'm saying these fast, but you can just push pause or just compare the notes that I gave you, write down the definitions. You need to know the following polygon names. So a polygon is a simple closed curve that is the union of line segments. So all the sides are straight. These I think you know. Most of us know are pretty good with hexagon and octagon. So you'll need to add in heptagon, which is 7, nonagon, which is 9, decagon is 10, and dodecagon is 12. Okay, on a polygon, the sides are the line segments. The vertices are the endpoints or the corners. You may want to think of them as the corners. And don't worry about adjacent sides and adjacent vertices. Which of the following are polygons? So I'm just going to take my highlighter and cross out. This is curved, so it can't be a polygon. This one is curved. This one has a hole in it. And this one is, I don't know what's wrong with that. And this one has a line sticking off of it. So that's not a polygon either. So only number 2 is a polygon. Diagonals go from one vertex to the other. Draw the following and tell how many vertices they have. So let's try one or two of these. A triangle has actually no diagonals. So if I try to draw a diagonal, there I can't. Quadrilateral has 4 sides, and I will get 1, 2 diagonals. A hexagon should have, ooh, I don't know if I can draw it with my mouse. There we go. So there's 1, 2, 3, 4, 5, 6. So there's going to be 3 from each side. Nope, because that one's already been drawn. 7, 8, 9, 10. 9. You can do hexagon. Types of triangles. On the chart that I gave you, on the notes that I gave you to fill in, there is a chart with the types of triangles, but these are the different types of triangles. So you can have an acute triangle. All 3 angles need to be acute. But if I have a right triangle, I only need 1 right angle. I can't have 2, so it's only 1 right. The same with an obtuse triangle. I only get 1 obtuse angle. An equilateral triangle means all 3 sides are the same. Scalene means all 3 are different. Isosceles means at least 2. So what that tells me is that an equilateral triangle is also isosceles. Then you have these quadrilateral definitions. So in a trapezoid in Texas, we get exactly 1 pair of opposite sides parallel for a trapezoid. If you went to school in a different state, this is a different definition, but we use exactly 1 pair of opposite sides parallel. And then in a parallelogram, you have 2 pairs of parallel sides. And then that makes them also the same length. There's a chart in the notes that I gave you to fill in. An isosceles trapezoid, these 2 sides are equal. And a rhombus is what is called a diamond in like little kid puzzles. All the sides are equal. In a rectangle, what makes a rectangle special is it has all right angles. So a square has all the sides the same and all right angles. So a square is a rhombus and a rectangle. We'll look at that in just a minute. Here we go. So every square is a rectangle. Despite what some people say, the answer is yes. Every square is a rectangle. I'm trying to get a different color. Yes. Because every square has 4 right angles, and so does a rectangle. If it is equilateral, it has 3 right sides, which also means it has if it's equilateral, it has 3 equal sides, which means it also has 2 equal sides. Can it be a right triangle and isosceles? Yes. I could have, say, sides 2 and 2, and then the other side would be the square root of 8. Don't worry about how I got that, but there's a isosceles right triangle. Some trapezoids are parallelograms. Not in Texas, they are not. Those two do not go together. Some isosceles triangles are scalene. Okay, well, isosceles means 2 sides are equal, and scalene means 0 sides are equal. So that's a no. Some isosceles, which means 2 or more sides that are the same, are obtuse. Yeah, draw yourself a big, like a rooftop. There you go, obtuse isosceles. Is a rectangle a parallelogram? Well, does a rectangle have 2 opposite sides that are parallel? Yes. Some rectangles are isosceles trapezoids, not in our world. These were both yes. I drew them, but I didn't put yes. Some right triangles, can it be right and scalene? Yes. It could be 2, 3, and I think that comes out to the square root of 13 or something. And again, I'm just doing Pythagorean theorem in my head. Don't worry about that. That doesn't matter. But you know you can have a right triangle where all the sides are different. Can you have no sides the same and all sides short? All angles acute? Yes. So you need to know the definitions well enough to answer questions like this. Okay, not just know the definitions. So the first step is to download the notes, fill in all the notes, and then use the Quizlet link to practice the definitions until you really understand what they mean and the relationships between the types of triangles and the types of quadrilaterals. Okay, happy memorizing.